Welcome back to our Six Sigma series. In the previous video, we explored the define phase, identifying the problem and setting clear goals. Now it's time to move to the next step, measure, where we convert our problem into data. Remember, if you can't measure, you can't improve it. We've defined the problem, set a clear goal, and identified who our real customer is. Now it's time to move to one of the most crucial stages in the DMAIC journey, the measure phase. Think of the measure phase as putting your process under a microscope. This is where we stop guessing and start knowing. In the define phase, we often work with assumptions or what we believe might be happening. But here, in measure, we look for facts backed by data. Improvement without measurement is like driving through a fog. You might be moving forward, but you have no idea if you're actually getting closer to your destination. That's why the measure phase is so important in DMAIC. It gives us clarity, it clears the fog so we can truly see where we stand. Measure gives us three essential things. First, a clear baseline, a snapshot of our current performance. This helps us understand where we are today before we make any changes. Second, valid metrics that are directly linked to customer expectations. These metrics tell us whether our process is really delivering what the customer values most. And third, confidence in our data. Because our analysis is only as strong as the data behind it. In this phase, we ensure that every piece of data we collect is accurate, trustworthy, and free from bias. So, think of the measure phase as turning on your headlights. It illuminates the path ahead, helping you move forward with certainty and precision. In the measure phase, our objectives are clear. First, we define the key metrics, the critical to quality measures, or CTQs, that truly reflect customer expectations. Next, we build a solid data collection plan, identifying who collects the data, what needs to be measured, where and when it's captured, and how it's done. Then, we validate our measurement systems to ensure both tools and people deliver accurate, consistent results. Finally, we establish a performance baseline by calculating DPMO, sigma level, mean, and variation. Step 1. Translating the voice of the customer into measurable CTQs. Every improvement journey starts with understanding what the customer truly values. When a customer says they want fast response, we cannot stop there. We need to translate that into a measurable term, something we can actually track and improve. For example, fast response could become average speed to answer in a call center or time to resolution in a service process. Similarly, when customers talk about accurate information, we turn that into metrics like first contact resolution or error rate. The key is to move from vague expectations to clear, quantifiable measures. This step ensures that our CTQs, or critical to quality indicators, reflect the customer's voice in measurable form. Before moving ahead, always ask this powerful question: how will we know if this improved? If you can answer that clearly, you've successfully captured the voice of the customer in measurable terms. Once we have defined our CTQs, the next step is to decide exactly how we will gather reliable data to measure them. This means more than just saying, we will collect data. We need to define the full plan: who will collect it, what data will be recorded, when and where it will be captured, and how collection will continue. The plan should clearly identify the systems or tools that will feed us information, along with the sample size required to represent the process accurately. Let's take a call center example. Your plan should clearly define the start and end dates for collection, which queues or campaigns will be included, and whether you capture voice calls, chat transcripts, or both. Remember, a good data collection plan is like a recipe: Anyone should be able to pick it up and replicate your results without confusion. Consistency and clarity are what make your data trustworthy, and that's the foundation for any meaningful analysis that follows. Step 3. Validate your measurement system. This step is often skipped, and that's risky. If your data is unreliable or inconsistent, your analysis will mislead you. In simple terms, if what you are measuring isn't accurate, your conclusions won't be either. For quantitative measures, we use a study called Gage R&R, that's repeatability and reproducibility. This analysis helps us identify where variation is coming from, whether it's due to the instrument, the person measuring, or the process itself. For qualitative metrics, check inter-rater agreement. Do different auditors score the same call the same way? If not, refine your checklist and retrain. A validated system means your data truly reflects the process, not the noise, and that sets the stage for accurate analysis. Step 4. Collect the agreed data and build your baseline. Now that your plan is ready and your measurement system is validated, it's time to start gathering data. Once collected, visualize it, plot control charts, create histograms, and run basic summary statistics like mean, median, standard deviation, and percentiles. Next, quantify how your process is performing. Identify the current defect rate and, if needed, convert it into DPMO or a sigma level to express performance more clearly. This baseline represents your process's true capability right now. It becomes your North Star, the reference point you will use later when testing improvements to see how far you have come. In the measure phase, the tools you use make all the difference. Start with SIPOC and process maps. They help you define your process boundaries clearly and understand where data should be collected. Then, use data collection sheets and sampling plans to ensure your data is reliable and representative. Next, apply measurement system analysis tools like Gage R&R for numerical data and Kappa analysis for qualitative assessments. Both confirm that your measurements are consistent. Use control charts to check if your process is stable over time, and Pareto charts to highlight the biggest problem areas. Finally, organize everything into simple dashboards so stakeholders can easily track progress and insights. Together, these tools help you measure with confidence before moving into the analyze phase. Let's take a quick call center example. Customers are complaining about long wait times. From the define phase, we know they expect calls answered within 30 seconds. In measure, we turn that into clear CTQs, average speed to answer and percentage of calls answered under 30 seconds. We create a data plan, pull system logs for 2 weeks across all inbound queues, sample 2,000 calls, and track average speed of answer, abandonment, and after-call work. A Gage R&R confirms the automatic call distribution timestamps are accurate. After testing data, we find the average speed to answer is 82 seconds, and only 28% of calls meet the target. A Pareto chart shows 60% of long waits happen between 10 a.m. and 12 p.m. With that, we have built a reliable baseline and identified our hotspot, ready to move into the analyze phase to find the root causes. Watch out for common mistakes in the measure phase. First, avoid picking vanity metrics, numbers that look good but don't reflect what the customer truly values. Always make sure your measures link directly to customer needs. Second, be careful about bias sampling. Don't collect only the easiest or most convenient data points, like short calls or specific shifts. That can distort your baseline and hide real problems. And third, never skip the measurement system analysis. If your data isn't accurate or consistent, your results won't be reliable. Avoid these pitfalls by validating your measures, clearly documenting your sampling rules, and involving frontline staff in the process. They often notice gaps or practical issues early, and that's what ensures your data truly represents reality. By the end of the measure phase, you should have a few critical deliverables in place. First, a clear list of CTQs and their operational definitions, so everyone knows exactly what's being measured. Second, a completed data collection plan that outlines who collects what, when, how. Third, validated measurement systems, confirming your data is accurate and consistent. Fourth, a documented baseline with metrics, charts, and process performance details. And finally, an initial list of prioritized problem areas to explore in analyze. These handoffs are essential. Without them, the analyze phase becomes guesswork, but with them, you are building on solid, data-driven ground. Now that we know what and how much is happening, it's time to ask why. In the next phase, analyze, we will dig into root causes using the baseline we built here in measure. We will test hypotheses and identify the true drivers of variation, the ones we can fix. But before we measure, a quick rule: if your measurement system isn't solid, stop and fix it. No fancy analysis can save bad data. That's the measure phase, where uncertainty becomes evidence. If you are working on your own project, pause now, write down one CT, create a 2-week data collection plan, and run one quick MSA check. Small, disciplined steps in measure pay off massively in the analyze and improve phases. Hit like if this helped, and let's move to analyze, where the detective work begins. See you in the next video.